Swayam Prabha. Digital India. Educated India.
Hello, good morning. This is Professor Abdul Samad. I will be teaching your GN course. 1.5 hours I will take class. Professor Zhu already has taught about 18 hours, and then I will teach some portion. Then after that, Dr. KG Vijay, he will be taking over, and he will be teaching, I think, mooring part. I will be teaching tidal energy and different types of energy which Professor Zhu most probably has not covered, because I have not listened all the lectures. But I assume the tidal, wind, this part are not covered, turbine part not covered. So, my expertise is basically compressor turbo machine. So, I will try to focus on that, and if you have any question you can ask also in between. Okay. So, today's content introduction I will give something, then I will talk about turbine, marine energy already you know, but some more thing I will try to add. So, I will talk about turbines, different types of turbines, and I will talk about something about my research, not too much, some touch I will give. Okay. So, if you see turbine, there will be different types of turbine. You have seen wind turbine, right? One vertical mast will be there, then there will be 3 blades, right? 3 blades will be there. Okay, you have seen this 3 bladed wind turbine. So, wind turbine, this is vertical axis turbine, and when wind will be flowing in horizontal direction, it will be rotating. So, this is axial flow machine. Okay, this is axial flow. So, wind turbine will have 3 blade, 1 blade, 2 blade, 3 blade, and this is axis, and fluid is parallel to the axis. So, that is called axial flow machine. So, some machine will be there, radial flow and other type of flow. So, first start with axial flow machine. Okay, axial flow, this wind turbine is also low head or low pressure or low velocity machine. Okay. So, if you see hydro turbine used in dams, river is there, you create dam and you pass high pressure, high velocity fluid. So, that will be high pressure turbine. Gas turbine, those are high pressure turbine also will be there in that case. Okay. Wind turbine is low pressure, low head, like ceiling fan you have seen, that is also low pressure, low head machine. Okay. But high pressure, high head when you are talking about, so large amount of energy will be there. So, their story will be different. Wind turbine, they have limitation in power extraction. There will be one term called base limit. Okay. This says like less than 60% energy can be harvested or extracted, remaining thing you cannot extract. Okay. Okay. So, before going to further details, let us see this India's energy scenario. Energy scenario, you have seen this, India is importing lots of oil from outside country, and because of geopolitical issues that becomes sometimes very difficult. Okay, so Middle East or Russia, some many other political issues are happening. So, that fluctuations happen. So, normally what happens, India will be importing oil from many countries, not from depending on only one country. Why? Because if one country is having political or some other trouble, then there will be lack of supply. So, India will be depending on like Saudi Arabia, Iran, Russia, USA and many other countries also. Okay. So, that one country is having difficulty, other supply should be continuing, and we are importing 80% oil. So, if there is any difficulty in importing, then we will be in trouble, right. So, we have to reduce this dependency, reduce oil dependency, and reduction not only for this import issues, there will be climate change issue. Okay. Lots of government is having that much of facing that question, how much pollution, how much hydrocarbon we are burning. Okay. So, how to reduce hydrocarbon consumption, and we can depend more on renewable energy or fossil less system we can generate. Like for example, hydrogen energy you can produce from renewable systems, marine energy you can use, wind energy, tidal energy, biomass, biodiesel. So, all these things we can use and we can reduce dependency on oil. So, it will be giving double benefit for India, import will be lower. So, our total import, the money we are giving to other countries, it will be more than GDP of certain country per day consumption. like Nepal, Sri Lanka, small countries, if you see their total GDP and per day import money for India, it will be more than that. Okay, because so huge, big country, so huge consumption is there. So how to reduce consumption? There is no way of reduction. Consumption will be increasing. Why? Because you are getting more money. Yeah, our living standard increasing. Living standard increasing means everyone is having mobile phone. I am talking using computer. Electricity is being used. Now, if you see trains, if you try to book trains, Indian trains, AC tickets are booked fast than your sleeper class tickets. That means people wants more comfort. You have little bit money, so buy comfort. AC ticket means more electricity consumption. Okay, more hydrocarbon consumption. Normally trains will be run by diesel or electricity. Coal trains almost gone. Only heritage train will be there in I think Darjeeling and your Uti train. 2 heritage trains are there for coal burnt system, but others are all diesel or electric based. So diesel, electric based both are coming from, most probably coming from hydrocarbon. Diesel already hydrocarbon, and electricity may be coming from hydroelectricity or NTPC, National Thermal Power Corporation. Thermal power, they are producing electricity from coal. Okay, coal, some coal we are getting from India, and many a certain amount of coal we are importing from other country. For example, Australian coal. Okay, you may have seen lots of work and Australian coal will be written there. Okay. So we need to focus on renewable energy. We have to reduce dependency, but dependency on fossil fuel. Electricity use or power use we cannot reduce. Living standard increasing, so your consumption increasing. So what is happening like this? With time, your consumption increasing. Okay, if I say this is time, consumption increasing, but our reservoir, oil, gas, coal reservoir, this is limited. So our reservoir, that is not increasing. Okay, reserve, this is consumption. So what is happening? One gap is happening. Okay, so how to fill this gap? If you do not fill this gap, there will be power cut regular. Okay, so many states they will have lots of power cut, right? Everyday power cut. In IIT we do not get face that issue, but many other states, many other places, rural areas, they will have lots of power cut. Means few hours power will be coming, then 2 hours gap, then again few hours, then 2 hours, 3 hours gap, something will happen, right? So because of this gap. Okay, and now how to alleviate the issue? Issue is that renewable energy have to depend, and another issue is that whether can we develop technology so that energy consumption can be reduced. Okay, so let us say efficient air conditioner you are using, so 5-star rating, all these things, so they will be using less power, and LED bulbs are coming, right? Filament bulb gone almost, even tube also gone. So less power consuming system we have to use, so that energy consumption reduction must be lower, I mean losses must be lower when transmission is there. So losses you have to reduce somehow. Okay, again you have to focus on new technologies, maybe new material, new technologies. Okay, and coal, yeah, so coal is limited in India, so you are importing. And oil locations, if you see, we have Bombay High offshore oil location. Okay, and other land based oil is there, Krishna Godavari region is there, Assam is there, and Bombay High, that offshore location 200 km from Bombay coast. So it is giving about 14% of Indian oil. Okay, so huge amount. It is giving from I think 1974. You can cross verify this one. About 1974, about 50 years, it is supplying oil and gas to Indian main country, but 14% of India's requirement. So still lots of requirement is there. Okay, and reserve, every day we are not getting new reservoir, but your requirement increasing. So that is a major problem. And climate agencies, climate change, IPCC, all this, they are asking to reduce hydrocarbon and the carbon emission. Okay, so multiple challenges are there. Now India government is planning for like Vision 2047, Vikasit Bharat 2047. Vikasit Bharat means how to reduce carbon. So you have to reduce carbon consumption along with other issues, right? So we have to work hard on this side. So we need more researcher, more scientists to work on this one. Okay, only politician cannot do. we need researchers, scientists who will be working actually. Politician will tell lots of things, but we need researcher. Geopolitical issue, I already told that if there is any geopolitical issue, there will be supply issues, then that will be creating a problem for Indian supply. Okay. Then when there is any supply problem, then that will create multiple other issues. Okay. Now strategic oil. What is strategic oil? Strategic oil is that India importing oil and gas, and because of certain disruption, India is not getting sufficient amount of oil. 80% you are importing, and finally 10% got cut because of this political and other issues. Then how to survive, right? So India has underground storage system, many underground storage. So they will be digging cavity, and they will be insulated properly so that oil leakage should not be there. And in that case, they will be storing crude oil. Okay. So India presently, I think 3 months storage is there. So if there is any issue, India can use 3 months. US, Israel, they have 6 months. Okay. So if there is any political and other issues, 6 months they can survive. After that, they will have to depend on others. India can maximum 3 months they can survive. And initially what they do, they say completely that oil supply cut. So in that case what they will do, first they will give oil to military operations, because they will be controlling the country. Then if still remaining, then public will get. Okay. So there are 4-5 such reserve in India, and India strategic oil reserve, if you search in Google, you will get it actually. Okay. It is called strategic oil reserve. Okay. So although you are doing strategic oil reserve, trying to explore everything, but this will not solve your problem, and you will not reach to 2047. This is actually 100 years of India's independence. Okay. So whatever government is visioning to make it beautiful developed country, so that will not happen if all we do not work together. Okay. So major exporting countries for India like Saudi Arabia, Russia. Now you have seen lots of news, right, because of political issues. Russia is there, Iran is there, and Middle East, many other countries are there. UAE is there, Qatar is there, USA also export. Many times what happens, although small country, for example USA may not be exporting, but because of strategic relationship, they will be exporting something to India, India will be importing something. So maybe certain quality oil they will be importing from US, certain quality oil they will be giving to, so that strategic relationship will be maintained. Okay. If there is any issue, so certain country will be supplying. So there, if any disruption is there, so 100% disruption must not be there. That is why multiple country relationship will be there. Okay. If you are depending only, say, only one country, and that country called trouble, then you are also gone. Okay. So that is why they will have multiple country relationship, two-way relationship, so that everyone can survive. Say another term will be coming, peak oil, because we are talking about energy. So all this term also you should know actually. Peak oil, if you Google search, you will see the term peak oil. So many scientists are saying that we have reached maximum oil production globally, not only India, globally. So with time, so initially oil production was lower, okay, then it reached maximum, then there will be declination. Why declination will be there? Because you are not exploring more reserve, or you are not getting more reserve, but your production rate increasing because your consumption increasing. Okay. So consumption increasing, production not increasing, and many well bore or reservoir is getting dried, you are taking all the oil out. So finally you have to abandon the oil. Okay. In any reservoir, if 30% oil remaining, then it will not be economical to produce oil further. Okay. So 30% oil will be remaining, but still you have to close the well bore because it is not economical. Okay. Many scientists are saying like already we have reached peak portion, now we are declining. Okay. Now if it is declining, so we have 2047, right? I said one target, government's target to make developed India. So whether that time we will have zero oil, zero hydrocarbon, not possible. Why not possible? So oil and gas is still cheaper energy, cheapest one. Okay. And whatever you are seeing, wind, solar, basically wind, solar, right? In India, because of temperature, we are getting lots of solar energy. Still, government is giving subsidy. Still, it is expensive. Then oil. Okay. So first you have to make this one cheaper. Our technology must be taking up, and oil price should have gone up little bit. Then maybe there will be balancing. Then people will take more. They will be depending less on oil and gas. Okay. And oil is not giving only oil and gas. That crude oil, whatever you are getting from wellbore. So it is giving you naphtha and other chemicals also. Okay. Tar, right? Road construction, plastics, lots of medicines also coming from oil and gas. So because of that, that oil production will be continuing next 100 years also. But maybe dependence will be reducing, consumption will be reducing, but production will be there. So there will be no stoppage actually. Although we are saying peak oil gone, oil will be zero. So there is not going to be zero, it will be there. So only one thing is that you have to work more on alternative sources, so that you can reduce dependency. So that will be your big strategy. Okay. So if you want to see your country 2047 as a great nation, then you have to work more on renewable side. Okay. Oil and gas side also you have to do, because more new technology you can develop, so that less energy consumption, less pollution can be done, but more you have to work on renewable and other sources energies. Okay. So India's electricity production, you see this electricity production, China, they are huge, they are producing. This is a little bit older information, 2019 data. USA, then India, Russia, because of larger country. Okay. Some country may be small, that is why total volume will be lower, but their actual production actually higher, if you see per capita something. Okay. So your many countries, they will be defining their living standard based on electricity consumption. If you are consuming more electricity, means you are more developed. That means you have more electricity you are using for air conditioner, heating, water supply, or electronic item running. Okay. So the lower developed countries, they cannot afford electricity maybe, or their supply may not be continuous. So electricity consumption low, their economic development also low. Okay. Okay. So if you see in India, fourth largest consumption, again it is also a little bit older, but still almost same zone it will be there, right. So production horizontal line almost, consumption increasing. So that is the challenge. Then how can you match this 2047? Okay. So there is a big challenge remaining ahead of you. Okay. So you need renewable energy or alternative energy sources. Okay. Renewable energy, alternative source may be nuclear, that also can be one option, or maybe some other source you can find. So renewable sources basically solar, biomass, wind, hydro, geothermal, marine. So this is our topic, but this is very much challenging. Okay, many countries are working, India, US, European countries, China, Korea, Japan, but still some technologies in the basic stage, especially wave energy you have seen, like people are trying commercialization, but still some resistance is there somewhere, right. Tidal energy, many places people have installed actually. If you see, if you Google search, there will be I don't know pronunciation, the spelling is there, La Rans. So actual pronunciation I don't know, French. They have one, I think 250 megawatt turbine system. South Korea, they have Sihwa Lake. Sihwa Lake tidal turbine system, I think they are the largest one, South Korean one, 256 megawatt I think they developed. Okay. There will be many other smaller tidal turbine systems, these are practically done. Okay. So this French one, they are running more than I think 50 years, and Sihwa Lake, this South Korea one, I think last 10 years, 15 years they installed, and the world largest one. Okay. Nearby Seoul, they put one dam, and when tide will be going, so tide will be crossing the dam and water will be stored, again tide receding, so water will be passing through the turbine and turbine will be rotating. So both way turbine will be rotating and they will get energy. So 256 megawatt I think. Okay, you can verify with your Google. And this geothermal energy, India also source is there, but majorly Iceland they are using. Okay, they have lots of geothermal sources. Geothermal source means earth, under the earth, the earth surface, temperature very high. So, temperature very high, you can use that one actually. So, high temperature and surface temperature low, run one turbine system like you know Rankine cycle, right? If you are mechanical student, then you may be knowing Rankine cycle. Rankine cycle means boiler is there, turbine is there. So, boiler boiling water, that will be creating steam passing through turbine. So, turbine rotating. So, cool the turbine, that steam, it will be liquid again, put into boiler will be boiling, again boiled steam, water boiled, then steam produced, steam passing through turbine, run turbine. Okay, so continuously this cycle will be going on. So, it's called Rankine cycle. So, geothermal energy also you can run Rankine cycle, you can get energy. Okay, so temperature difference is there, you run the system like it is like this. I will draw like this. Boiler. Okay, boiler means boil water, create a steam. So, that steam will go to turbine. Okay, so turbine will be extracting energy like wind turbine extracting energy from air. So, here high pressure, high temperature steam will give energy to the turbine. Okay. So, turbine I am drawing a certain way, later I will explain why I am drawing like this. Okay. Then condenser will be there. Okay. From condenser there will be one pump, from pump it will be going to boiler again. So, this cycle will be continuing. So, steam, turbine will be taking energy, then steam will be going to condenser, you will form liquid water, water will be passing through pump, pump will be delivering to boiler again, and boiler will be giving steam again. So, this whole cycle will be continuing. This is called Rankine cycle. Okay. This is steam power plant, they will be running like this. Okay. Like NTPC, whatever thermal power plant is there. So, PC, so they will be running like this. So, boiler will be getting energy from coal burning. Okay, you burn a coal like you are boiling tea, right? Similar way it will boil and turbine rotating continuously, things will work like this. So, geothermal energy you can use like this. So, another system also there, OTEC, Ocean Thermal Energy Converter, I have written there. So, I will explain little bit details later. So, OTEC also works on the similar principle, Rankine cycle principle they will be working. Okay. And already wave energy you have seen, and salinity driven and tidal energy I will explain. So, you have to remember that there are renewable energy, solar, wind, biomass, hydro. Small hydro means small hydro, small water falling, like you have seen that Swades movie, right? Shah Rukh Khan is doing the turbine putting and getting energy. So, that small hydro energy. Okay. So, that also renewable energy, and marine energy all are renewable. Okay. So, yeah, this is also little bit older news, 2019, target 175 gigawatt by 2022, already 22 over. So, I have to check latest data, but India government is focusing more on wind and solar. The solar, because temperature is very high, like sun radiation is very high in India. So, they are focusing on solar energy, and wind also there, lots of investment is going on for solar. Offshore solar also government has allocated fund. So, that also going on. So, turbine. So, I said turbine, every time turbine. What is turbine? Turbine, you have seen fan, right? Ceiling fan at your home, wind turbine you have seen. So, ceiling, then first I will say turbo machine. Okay, turbine, fan, we say turbo machine, it will be coming under turbo machine. Then it will have two parts, one will be pump, one will be turbine. Okay. So, I put two terms, pump and turbine. Turbine means taking energy from fluid, taking energy, okay, and pump giving energy to fluid, just opposite. Okay. So, although the term pump is used, normally I use the term pump for liquid pumping. When you are giving energy to gas, we say compressor or blower or fan. So, then other terms also you can use like compressor, blower, fan. fan, ceiling fan, it is giving energy to fluid, electricity you are giving, then energy to fluid, fluid is getting circulated, right, you are getting creating turbulence on your head nearby. Ceiling fan. Blower, many places industries they are using blower, so blowing some item, right. Compressors, compressors means you are compressing air in many cases, those will be coming under pump category, or instead of pump you can use other name also, no issues. And turbine, it will be taking energy from fluid. So steam, I already told, steam will be giving energy to turbine, so we will get electricity, or will be giving gas turbine, gas, high pressure gas also pass through turbine, you can get energy. Wave, ocean wave also can give energy, tide also can give energy, river, okay, so those are turbine, okay. So gas turbine actually it is like this, although it is not topic or thing, but I will explain like this. So gas turbine normally you draw like this. So gas turbine will have compressor and turbine, okay. So gas turbine will have one turbine and compressor and it will be running. So normally yeah, so there is no renewable energy thing, it is hydrocarbon you are burning, you are getting energy, and normally aircraft engine they will be using, okay. Steam turbine, already NTPC or thermal power plants they are using, okay. OTEC system, ocean thermal energy converter, also using similar concept as steam turbine, Rankine cycle, I will explain later. Hydro turbine, hydro turbine is high pressure fluid is there and you are running turbine, like wind turbine, low pressure wind blowing, turbine rotating. Hydro turbine, high pressure fluid going, turbine rotating. So hydro turbine will be giving more energy, because energy more in water. For wind, energy less because of density, right, water density 1000 time of wind, right. So that means 1000 time more you can get. So smaller turbine will give you more energy, wind turbine you need bigger turbine, you want to get 1 megawatt. So small hydro turbine can give 1 megawatt, but wind turbine will be requiring very high, tall, more than 150 maybe meter diameter, right. So if water is having higher energy, maybe because of density change or maybe flow velocity or pressure, it will give more energy, okay. So in our tidal case, normally it will be low head, low pressure turbine, tidal energy. Wind turbine also low pressure, low head turbine, but when you are going for steam turbine, gas turbine, or dam and hydro turbine, those are high pressure, high head turbine, okay. So normally we discuss about low head, low pressure system for our marine energy application, okay, because lower amount of energy is there, we try to extract energy, okay. And wind turbine, other type of tidal, okay. So let us focus on marine energy. You will be seeing this picture, actual thing I think you have seen already, our wave basin area. Tomorrow I think you will see, okay. So why do we need marine energy? World population increasing continuously, and European Union has target 10% marine energy to use, okay. So marine energy does not mean it is wave energy, it is a mix of all type of energy. Ocean covers 75%, 70% earth surface, okay, and 70% earth surface means lots of wave. If you can extract wave or tide, that is very good actually, you can supply all energy from the ocean itself. India is having 75%, 7500 kilometers, okay, coastline. So if you can use that one properly, so you can get good amount of energy from the Indian coast itself, especially islands or coastal areas, they can be powered using your marine sources, okay. So yeah, so if you want to make future green and 2047 target, then you have to work hard, okay. Indian oil import I already told, okay. So if you see marine energy, basically there will be this energy whatever we are discussing, actually energy from water, wave energy, current, thermal, osmotic power. Another energy is there floating solar and wind. Wind energy, wind turbine you are putting in ocean area, so you are not taking energy from ocean water, because land accessing difficult sometimes, so you are using ocean. So that sometime we put in ocean energy area, but that is not ocean energy actually, you are using that land only. Floating solar also you are using that ocean surface, right, you put solar panel and sunlight will be falling and you are getting energy. So, you are not using water or any ocean thing, only space you are using, right. So, wave energy already you have discussed, there are several types: point absorber, oscillating water column, overtopping device, right, and current or tidal energy. So, tidal energy basically turbine based energy, okay, basically turbine based, some other type of also there, but basically turbine, okay. So, turbine is low head turbine, okay, you should remember this is a low head turbine. Low head turbine means you are getting less amount of energy, okay. High head I already told, the gas turbine, steam turbine, hydro turbine, those are high head, high pressure, okay. And thermal energy, ocean thermal energy converter I will discuss later. Ocean thermal energy, how does it work? Actually, if you see seabed temperature, it will be 4 degree. You know the reason, I think in class 8 9th book you have studied seabed temperature. At 4 degree water density will be highest, okay. So, when surface that cold water, high density fluid will be going down, and at 4 degree highest temperature, so water will be taking the seabed, nearby seabed area, and whenever it will be getting heated up, it will be coming to the surface, okay, because of expansion, okay. So, this cold and high density fluid will be the bottom and low density hot will be on the surface. So, temperature difference I got, this is 4 degree, this is maybe in India it will be like 30 degree around surface, this is around 4 degree, okay. So, NIOT, National Institute of Ocean Technology, you know already, this is nearby IIT Madras, Pallikaranai. So, they have developed ocean thermal energy converter, and their temperature difference about 20 degree, they are running their system in 20 degree temperature difference. In steam turbine, your temperature difference will be 400-500 degree centigrade. Steam turbine actually, National Thermal Power Plant, all this corporation, NTPC, they are running their system 400-500, right. And in our ocean thermal energy converter system, it is 20 degree around, plus minus 20 degree centigrade difference, okay. So, ocean thermal energy is called OTEC, ocean thermal energy converter. So, how does it work? You have low temperature, you have high temperature, you create one ammonia loop, okay. At high temperature ammonia will be boiling, boiled ammonia, that is steam, you pass through turbine, bottom it will be cooled down, liquid ammonia, again it will be steam, turbine, the same Rankine cycle, okay. So, seabed, so there condensation happening, okay. Then condensation to boiler, boiler means surface, sea surface you are going. So, condensation happening as 4 degree centigrade, 4 degree centigrade, surface temperature, water surface about 30 degree, okay. Then boiled, it will be going to turbine, from turbine what will happen? Again you are sending that steam, low pressure steam to your condenser. So, the cycle will be going on. So, that cycle is actually Rankine cycle, okay. So, you are using normally ammonia as your working fluid, or CFC and other fluid also you can use, okay. This simple Rankine cycle, and with very low temperature difference. So, that is why your efficiency also low, efficiency also will be low, because very low temperature, high temperature difference means you can get more efficiency, okay. And this is also very challenging to work, like if you have land and you are working on low temperature, that much difference, that will be okay. But sea means getting 4 degree and 30 degree, that will be maybe 1 or 2 kilometer, 1 or 2 kilometer water depth, right. Then in the ocean, like several kilometer away from your coastline, how to hold there? You have to make some structure, or maybe you will be putting your structure on land, then you have to put pipeline, because you have to access the cold area, hot area. So, hot area if you are accessing maybe directly, but cold area then you have to put several kilometer pipeline, then suck the fluid, you have to run one pump, right, cold fluid pump, then steam, then turbine, then again put that one into cold area, okay. So, that will be going on. So, that is why it is expensive also, efficiency also lower. So, that is why many countries still trying, okay, many countries still trying, like US in Hawaii, Makai Island I think, they are trying. India NIOT, they have developed their laboratory and they are trying to give sea water, desalination water to coastal people. Coastal means islandic people, Lakshadweep and Andaman. We have some islands, so they need drinking water, power also they need. So, initially they are trying to provide drinking water using this OTEC system. So, they will be getting power, so that will be desalinating water and they will give to the local people. Okay. So, why this islanding people need the water? We are getting water like municipality water coming and you are happy, like can is there, you can drink, but their problem is that all around water and several 100 km away from mainland. Okay. So, you cannot give direct electricity from mainland, long cable, it will be expensive. Next thing is that you say, sir, I can give diesel or coal, some power plant you can construct, then who will carry that fluid, the fuel? So, fuel carrying, especially winter, rainy season, turbulent weather, very difficult. Okay. Sorry. During turbulent weather, airplane or helicopter transportation or sea transportation, everything is difficult. Then you have to store there, then leakage issue may be there. So, they are already coral island actually, nearby coral reefs will be there. So, you cannot harm them. Okay. So, multiple challenges and greenery is there. So, you cannot cut and you cannot put solar panel. So, if you are putting solar panel on this island, so you have to cut trees, so not allowed. Okay. Coal and other, again fossil fuel you are burning. So, how can you avoid this one? Again you have to carry, you have to store for all season power supply. Okay. So, one way is that can you give power from ocean? Wind turbine you put, so floating solar panel you put, wave energy, tidal energy, current energy, osmotic energy, all the energy system you put, create a mixed bag, give energy to them. Okay. So, they need water, they need electricity. Okay. But you cannot harm their coral area, fishing, their livelihood, fish and other, those things you should not destroy. Okay. So, the main challenge is that how can you give that energy? Okay. It is expensive, government will be assisting you, but whether can you do some research and give some solution to them. Okay. So, ocean thermal energy, you understood that this is actually Rankine cycle, NTPC, same concept, but this is low pressure and expensive. Okay. And osmotic pressure means if you have one membrane, okay, density fluid is there, different density fluid is there. Let us say this is low density, this is high density, I think. This is low density. So, high density fluid column actually it will be living, if this is membrane, okay. So, low density will be fluid will be entering through the membrane to the high density fluid. So, this level will be increasing gradually, this column height. Okay. When column height increasing, so you put some hole maybe and you run one turbine. So, it is trying to lift your level and but you are taking out the water. So, it will be running a turbine. So, that way the concept is that osmotic pressure, because of osmosis one fluid column will be lifted up. So, that fluid column you use for running turbine or some other purpose. So, that will be giving energy. So, in India there is not much research happening now, US some try is happening, okay, but I think it is still in very basic stage. So, but how it will work for ocean energy? River water, sea water, salt concentration, sea water salt concentration you may be knowing 35,000 ppm parts per million. Your drinking water salt concentration 500 to 1000. Okay. You cannot drink if you have more than 1000 ppm actually, but if you have 35,000 ppm in salt in sea water, so this is very salty, you cannot drink actually, if you drink you will die. Okay. So, that much of salt, but river water salt concentration will be very low, maybe 100, 1000, 2000. Okay. If you have different salt concentration, that means one is high density, one is low density. So, now you create one membrane in between. So, membrane will be giving that rise of water column. So, use that water column rise for running one turbine. Okay. So, that way the OTEC system, osmotic system will be working. Okay. But lots of research will be required. Okay. Then why ocean? Ocean is the largest solar collector. Okay. It is absorbing solar energy and it is giving lots of renewable energy. Okay. Electricity can be generated by changing salinity, thermal gradient, tidal level change, ocean waves and currents. Current means actually because of ocean tides, current will be created. Number of ocean energy devices, more than 1000 will be available, different types, different variants. Okay. Ocean resources, if we can harness all the ocean energy, then it will be giving all, it will be fulfilling all energy requirement of the world. Okay. Because 70% of Earth's surface covered by ocean. So, ocean water especially. So, that will give all energy. So, you have to develop the technology. You can see some statistics taken from some long back 2006 data. So, huge amount of energy available. Okay, tidal energy, tidal energy, ocean wave, salinity gradient, thermal energy. Okay. So, you have seen in your school book, tidal tide is formed because of lunar and solar effect. Okay. So, if lunar, sun and moon in opposite direction, tide will be more, but if in perpendicular direction, tide will be less. So, because of that one, tide is getting created. What is happening? Tide, when water is moving in one direction because of solar and lunar effect, so water mass will be moving. So, when mass is moving, it will create on current, water flow. Okay. When again it is going receding, so again there will be another water flow, because the water flow, low head turbine you can run. Low head means low pressure, head we use the term head, head means actually pressure. Okay. So, head and pressure actually similar term. So, we are discussing about tide creation. So, because of tide creation there will be water flow, water mass flow, and because of water mass flow we will get energy. Okay. So, we will be running low head turbine. So, low head turbine will be giving energy. So, now you can see the wave energy, wind energy, solar energy, would take all these things, it is related to water, right, and actually it is related to sun. Why? First you see solar energy. Solar energy actually it is coming directly from sun, you have solar panel or maybe some other mechanism, so you can get energy. But wind energy, it is also coming from sun actually. Why? Because sun will be creating difference in temperature, because of temperature difference wind will be blowing. Now, next thing is that wave also coming from sun. How? Solar energy will be hitting water surface, then there will be uneven heating because of sun rays falling here and other time, wind will be blowing. So, wind is blowing over ocean surface. So, one small wind blowing, there will be one ripple. So, if you are crossing 100, 200, 500 kilometer, the small ripples will be growing up. So, when that is growing up, that is creating wave actually. So, finally, your energy coming from sun, right. So, sun is giving wind energy, solar energy, wave energy also. Now, ocean thermal energy, again because of temperature difference, where are you getting the temperature? It is also again sun, right. Sun is creating surface temperature and low temperature is there. So, again sun energy, right, and tidal energy again solar and lunar. So, sun is there. See, all the cases sun actually one part, right. So, tidal energy moon contribution also there, other cases sun actually 100% contribution, and wave energy is a concentrated solar energy. Wave energy is concentrated solar energy. Writing is difficult now. Concentrated solar, okay, and wind also solar energy. So, it is not so much concentrated, right. So, all the energy sources sun. Okay. Tidal energy can be harvested in one or two ways, directly from tidal stream or storing the tidal current. So, if there is any water flow, you put low head turbine, you get energy. In another case, you put some dam, when water, let us say tide is coming and water level increasing and you have one dam. So, water will be crossing this dam, it will be stored. When tide is going down, again water will be trying to pass and you make some turbine here, right. So, you have water here, one dam is here and put turbine here, okay. So, when tide is going, it will be passing through turbine, when tide tide going back, water mass going back, again it will be passing through turbine. So, both way you are getting energy. So, the Siwa Lake, South Korea, they made such way. So, bidirectional turbine. So, this way also they are getting energy, when going down again they are getting energy, both way, okay. But all are low head, low pressure turbine. Low head means, head means pressure. Head we say in terms of unit will be meter. Head means how much water column level can be raised. So, that will be in terms of meter unit. But when you are talking about pressure, pressure unit will be Newton per meter square per millimeter square, right, or Pascal, PSI, right. So, different types of tidal energy is there. Ducted turbine. So, Siwa Lake they have put ducted turbine, right. Oscillating hydrofoil, in some cases kite you have seen, right, many people will be flying kite. So, if you put similar sort of kite sort of design in water, so kite will be flapping like this, moving up and down, and when it is like vibrating, flapping, so you put some mechanism in, you harness energy. Like wave also you are having like vertical motion, right, up and down motion, and you are trying to harness. So, similar way if you put tidal kite, so kite will have flapping thing, okay, it will make move like this. If you see any kite also, they are not moving steadily like airplane. So, they will be moving like vibratory motion will be there. So, that motion can you harness. So, that way they are trying to harness, that is called tidal kite, okay. Inside water kite will be there, okay. So, their name is tidal kite, technical name they are using, okay. Vertical axis turbine, horizontal axis turbine already you have seen. Wind turbine, similar turbine you put in water, but wind turbine size 100 meter, but tidal turbine height will be only few meters, because water density, okay. Maybe same fluid flow rate, flow velocity, but wind turbine height will be much higher than tidal energy system turbine, because high density water high density means mv square, total kinetic energy more, because high density, rho is high, okay. High density means total energy, same flow velocity, v same, so density high. So, because of that total energy content in fluid is high. So, that high energy is there. So, that they can give high energy to turbine. So, turbine will be getting more energy, but in air density low, okay. So, it will be giving less energy to turbine. So, same energy you want to harvest. So, wind turbine size will be much bigger, tidal turbine size will be smaller, okay. Although both are low head turbine. And vertical axis turbine, turbine, I think I have picture. So, vertical axis turbine, you see this left bottom side picture, okay. So, this is vertical axis. So, axis will be vertical, and turbine blades are arranged such a way that whenever air is flowing like this, it will be rotating, okay. But horizontal axis turbine, axis was like this, air flowing, and it will be rotating like this, right. So, one is vertical, one is horizontal. So, two types of basically turbine. So, horizontal axis turbine size will be much bigger. Wind turbine you can see lots of big turbine, but vertical axis turbine size smaller. Normally like rooftop wind turbine you have seen, if you Google search or YouTube search, lots of videos will be there, rooftop wind turbine. So, there will be very small size thing. So, similar turbine also you can put in water. So, that will be vertical axis wind hydro turbine or water turbine or hydrokinetic turbine. The term they use hydrokinetic, kinetic energy is there. So, from kinetic energy you are harnessing energy. So, hydrokinetic energy, so hydrokinetic turbine they are using the term, low head turbine, okay. So, that sort of term they are using. So, you can note down also. Kite I was saying, like this type of kite they can use, like one kite is there. So, because of water flow, this will be moving, okay. Actually you are creating bluff body will be creating flapping like this. When it is flapping, he puts some mechanism, like MMR professor has designed, same mechanism you use there, mechanical motion rectifier, right. So, similar mechanism you can use, and you can harness energy, okay. And another type of is there Archimedes screw type. Archimedes screw means this is also low head turbine, or okay. I'll avoid mathematics part. Okay, some example of tidal turbine. You see Siwa Lake, South Korea, 254 megawatt turbine. turbine size 7.5 meter. Okay. I think 6 turbines they placed and they are getting 254 megawatt. But if similar turbine, similar energy you want to get from wind turbine, the turbine size will be too big. Okay. And maybe multiple turbines you have to put, and that will be very big actually. And France, this Rans tidal turbine station, actual pronunciation I do not know, I say Rans. Okay. They have 240 megawatt. So, South Korea is one of the largest one. Then Canada something is there, China is there, Russia is there, and many small turbine will be there everywhere, okay, in US and many other places. But they are the major big turbine, especially South Korea and France, those are biggest one. And yeah, tidal barrage, new research is going on, new companies are coming up. So, BISAG-N one company is there in the UK, so they are making barrage. Yeah. So, then in barrage they are putting turbine, axial flow turbine, especially axial flow turbine they are putting, and Vedant Power, Atlantis and many other companies they are trying to make turbine. So, some are axial flow, cross flow, different types of turbine they are putting. And this is our actually some of my students have done research on tidal turbine. So, whenever you are designing and optimizing, testing, so you have to know lots of parameter in tidal turbine. You have to understand aerodynamics. So, you can say hydrodynamics. So, how the fluid will be flowing over the turbine blades, like similar to wind turbine. So, water also will be flowing similar way. Okay. So, whenever we say turbo machine, turbine means turbo machine we say air, water does not matter, there will be some common flow phenomena. So, that will be they will be following. Okay. And this is the most complex flow situation in all fluid mechanics application. So, turbine flow, because you do not see air, but you are doing all the calculation and simulation, finally you are getting exact result actually whatever you get from experiment. Okay. So, scientists has developed so high level of computational power and mathematical capability, so that you cannot see air, but you do all the calculation, you find same efficiency whatever you get from experiments. Okay. So, there is fluid mechanics, so CFD people can do that. Okay. So, some of my student like Karthikeyan, he is in the UK, he did all this calculation. So, turbine blade, long turbine blade will be there, you can see this turbine blade. So, he divided turbine small size, because turbine one size larger, one size smaller. So, how the size changing? So, then he cut small pieces, he designed all this one part, then he lofted, he made the turbine blade. So, then one lofted, then he made 3 turbine blade, then he did all the simulation. Okay. So, you can see this, if you do CFD simulation, then you have to go for meshing, then you have to validation means comparing your result with existing result. So, if you see this result, bottom corner right side, so experiment and my students calculation is almost matching, right. So, CFD power you can see, although we did not see the turbine also, how that does it look like, just computer design simulate, we got similar result. Okay. So, CFD is so much accurate, and these days we have supercomputer, high speed computer, cloud computing also, there are new calculations, new development. So, you can do very high level of computation, you can get more accuracy actually. Okay. Some error is still there, you can see this experiment and KMK, some difference is there. So, if you use more sophisticated computer, more meshing, more calculation power, new methodology, so maybe you can get more accurate result. And then you do numerical analysis, then you go for design optimization, because you want to get maximum power from turbine. So, you design any turbine, you put in water, that may not give maximum power, may not be turbine, you wave energy, tidal energy, ocean thermal energy, osmotic power system, you design initial thing, the same thing may not be the efficient one, then you have to change the design, so that you can get maximum power from water or wind, whatever you are using, right. So, in that case what you would do, one way is that you do experiment, you design 10 different types of turbine and you test everything. So, 10 design means money involved, your time, so lots of things are involved, right. Like again, if you are going for ocean, so ocean where will you be testing, and in which water depth, where, right. Ocean is very difficult, because you do not know ocean fishermen they can handle, but you do not know ocean and you are to jump, not possible, right. 5 meter, 10 meter water depth, our height is less than 2 meter and 10 meter water, how can you work? It is not possible. So, to avoid that sort of thing, we go for numerical simulation. Some laboratory tests we can do in our laboratory, like tomorrow and day after tomorrow you can see some laboratory systems, but remaining thing we do in using numerical modeling. So, numerical modeling also as accurate as experiment. Okay. So, whenever doing numerical, you go for design optimization. So, you change your design parameter such a way that you can get maximum efficiency or power output from turbine or any system, wave energy or other system. So, in my group, my research group, my student will be doing like the design. Initially, they will be doing designing maybe 20 design in computer. So, 20 design in computer means it will take maybe 2 weeks or maybe one week only. But if you go for experimentation, actual manufacturing and design, it will take maybe 2-3 years. Okay. So, we will be doing all the numerical modeling and simulation, maybe in 6 months all the simulation will be done. Then still we do not know which one will be the better one. The simulation, let us say design 1 you simulated, you got efficiency 70%, simulation 2 you got 65%, another 75%, another 80%. So, you cannot say sir 80% that one is better one, maybe 81% is better, but your design does not contain that 81%, right, because 1% efficiency also will be good maybe, especially gas turbine application and those application which technology is very much mature, 1% efficiency increase is very high increase. Okay. So, then you got several design, you calculated, you find efficiency or power, then you do again another level of design optimization like surrogate modeling, machine learning thing you apply, then you try to find the best design. Okay. Their best design may not be the design you did already, that will be maybe new design coming from all these, averaging all this. Okay. So, that will be coming from machine learning and surrogate modeling. Okay. So, that steps we follow in our group. And so, for to do this one, to do this we do some sampling, proper sampling also required, then we go for surrogate modeling, then we get all the results. So, these are some results actually. So, how this design parameter and things are changing, if you see left and right, so how the modification done and different angle we modified and how the result came up. So, we compared and we published some result actually in our articles. Then when you are doing for fluid mechanics analysis, we try to see how the fluid physics changing if we change design parameter. So, fluid physics will tell whether our design modification is good or not. So, if fluid physics actually if you understand properly, then it will indicate somewhere that this design good or not. Okay. That we try to capture using post processing operation. Okay. So, I will go to okay, thank you very much. I will start new topic.